Have you ever picked up a wrench and just assumed it's always looked like that? Like it just spawned into existence inside a toolbox somewhere?
Yeah, like tools are born fully grown. No childhood, no awkward teenage phase.
Exactly. But the truth is, every single tool you own went through a pretty intense journey before it ever tightened a bolt.
We're talking fire, pressure, precision cutting, heat treatment, polishing, and more quality control than most of us get in life.
So today, we're going behind the scenes of how tools are made, from raw steel to the finished precision tool in your hand.
Everything starts with steel. Not just any steel, tool-grade steel, usually high-carbon steel or Chrome-Vanadium.
Which already sounds expensive.
It kind of is, but there's a reason. Regular mild steel bends too easily. Tool steel needs strength, toughness, and wear resistance. It has to survive torque, impact, and, let's be honest, occasional misuse.
You mean when someone uses a wrench as a hammer?
We don't judge, we just acknowledge. The steel is melted at extremely high temperatures, purified and mixed with alloying elements like chromium or vanadium. Those additions improve hardness and durability. Once the composition is right, the molten steel is cast into solid bars.
So before your wrench ever touched a bolt, it was basically liquid lava.
Pretty much.
Okay, so now we have a solid steel bar. What happens next?
Now comes forging. The steel is heated again until it's red hot and then pressed or hammered into shape using massive industrial dies.
And when we say massive, we mean machines applying tons of force.
That pressure isn't just shaping the tool, it actually aligns the grain structure of the metal internally. That's what gives forged tools their strength.
So that drop forged steel label isn't just marketing?
No, forged tools are generally stronger and more durable than cast tools. Casting is cheaper, forging is tougher.
So forging is basically strength training for metal.
That's surprisingly accurate.
After forging, the tool has its rough shape, but it's not precise yet. This is where things get surgical.
Exactly. CNC machines step in. Computer-controlled cutting tools refine the dimensions. The jaws of a wrench are milled down to exact tolerances. Socket interiors are shaped to grip bolt heads perfectly.
And we're talking about differences measured in fractions of a millimeter.
Which might sound tiny, but that tiny difference is what prevents rounding a bolt under torque.
So when a cheap wrench slips, that's not bad luck.
That's tolerance and consistency.
So now it's shaped perfectly. Done?
Not even close. Now comes one of the most critical steps, heat treatment. The tool is heated again and then rapidly cooled in oil and water. That process hardens the steel, but if it's left too hard, it becomes brittle.
Which means it snaps.
Exactly, so manufacturers temper it, reheating it slightly to relieve internal stresses and create a balance between hardness and toughness.
So it's like emotional maturity for tools.
Strong, but not fragile. That's the goal.
Once hardened, the tool gets ground and polished, edges are sharpened, surfaces are smooth, logos are stamped or laser etched. And then comes that shiny chrome finish we all recognize.
Chrome plating isn't just cosmetic. It protects against corrosion and makes cleaning easier. It also reduces surface friction.
So it's not just there for tool glamour shots.
Although it does photograph well.
At this point, it looks ready for the toolbox.
Not before testing. Quality manufacturers test tools for hardness, dimensional accuracy, and torque limits. Some tools are even pushed to failure in controlled environments just to understand their limits.
That's reassuring.
It should be, because when you're applying serious torque in a real job, failure isn't just inconvenient, it can be dangerous.
So here's the big question. Why do some tools feel solid and others feel like they came free with a piece of furniture?
Because not every manufacturer follows the same standards. Premium brands invest more in material quality, machining precision, and testing.
Which explains the price difference.
Exactly. You're paying for consistency, for reliability, for fewer surprises.
So next time you pick up a wrench or a socket,
remember the fire, the pressure, the machining, the heat treatment.
it's not just metal.
It's engineering.
And now you know how tools are really made.